howdy, this is Mr. Potter. In our next unit, we're going to be talking a lot about strings. Now, we've already talked a little bit about strings just from the notion of a string literal or using the string constructor to create strings. And we've also talked about how there are issues testing equality with strings and how we should use the dot equals method whenever we're dealing with strings or objects in general. I found this rather interesting example. This actually comes from Jody Paul. But we were talking about how to tell when to use equals or dot equals. So he came up with this example. So let's say we've got a string S1 being equal to yes, and a string S2 being equal to a new string yes. And so this is the two ways that we've talked about how to construct a string. One using the string literal, and the other one dealing with the string constructor. And what we notice is that if I was to try and system.out.println S1 equal S2 to use the relational equals operator here, what I'll find is that these are not the same thing. As a matter of fact, this creates one instance, and the fact that I use new here forces it to create a new instance of the string. But he brings up some other interesting points, because we do know that we can create a string by concatenation. So I could do y plus lowercase e plus lowercase s. And if I were to tweak this and ask if S1 was equal to S3, find out something interesting. I get true. And that's because this concatenation takes place before the assignment, and Java, in an effort to keep memory down to a low level, uses something called interning when it comes to strings. In other words, if some strings have the same value, then it goes ahead and assigns them the same memory location. So I've got a string called yes in memory, and I've got another string called yes in memory, and they are seen as the same string in Java, and so they are assigned the same string memory location. And so when I actually test using the relational operator equals, I get a true. He further talked about, okay, well, what if we did a different way of concatenation? So let's do y E, and then say S4 gets S4 plus S. So in this process, I've got a string that contains a Y and an E and an S. And it turns out, because the concatenation happens on successive lines, we actually will not get the same result. We'll actually get that it's false. As a matter of fact, this S4 is not logically, it's not equivalent to any of the three strings that we've come up before. So it's just an interesting way of looking at it. But I've got four strings here, all containing the string yes, and where they are in memory depends on how we construct the string, and even the order of when we constructed the strings. Because if I was to change this, so I did this first, and then did this constructor, they would not be in the same location either. So, interesting things. The main idea behind today's lesson is the immutability of strings. In other words, the idea that a string cannot be changed. So what's actually happening in this S4 is I have a string containing YE. And so on this row, I have a string that contains YE. On this second row, I have a completely new string containing YES. So the idea is that I'm not changing the string. I'm actually constructing a completely new string. And I need to know this because I need to know that any methods that I have for strings can't have any mutators in them. That's something that's important to know. We talked about constructing mutators with our fraction class that we were working with a couple of units ago. But strings are immutable, which means strings cannot have mutators. All they can have are accessors and assignment statements. And so with what we're going to talk about today, we need to be aware of that because strings can't change. I can't take S1 and say dot to uppercase, which is a method that would normally change an entire string to all uppercases. But if I system.out.println S1, I find out the S1.toUpperCase doesn't actually change the string at all. What I have to do to change the string is I have to say S1 gets S1 dot to uppercase. I have to make an assignment statement, and that changes it to this yes that we see down here at the bottom. So the toUpperCase does not mutate the string. What it does, in fact, is creates a new string, which we then have to assign somewhere else. So this statement by itself, if I was to see S1 dot to uppercase, doesn't do anything by itself. But if I assign it to the string, even assigning it to itself, then it does this. Now, when I say that strings are immutable, I need to be clear. I can assign a string to a memory location. So the thing is the memory location is not what's unchanging. It's the content of the string that's unchanging. Whenever I quote change a string unquote, I'm actually reassigning it a new value. That's just something to be aware of. So I've got this. S1 gets S1 up to uppercase, and I can print out S1. I have a similar method to lowercase. And then I can system.out.println S2. And so this would print out all lowercase. Notice that the capital Y in front is gone. And of course, these are completely new strings. They're not equal to each other because they don't have the same contents anymore. But what we can do is, even though we have the dot equals, there's some another tool that we have. We can actually do let me do a system.out.println to just skip a line. But we can also do system.out.println S1 dot equals ignore case. And what this does, this function is just like the equals method does, testing to see if two strings have the same contents, but I do it with ignoring the case. So it's ignoring the capitalness. It's just saying is the first letter in this string the same as the first letter in this other string, and so forth. And so if I run this, notice that even though S1 is yes and S2 is yes, they do equal each other if I ignore the case. And in fact, I could say, do system.out.println, and I can compare S3 equals ignore case with quote YES And I will have equality here because they do contain the same letters, just not necessarily the capitalization being the same. One other thing that I want to point out is that this toUpperCase and toLowerCase method that we've been talking about only affects letters. It doesn't affect numbers or punctuation or spaces. So if I wanted to say something like string S5 equals 1,000 miles equals 1,618 kilometers. And then I do S5 gets S5 dot to uppercase. And then I system dot out dot print line S5. What I'll find is that I get 8,000 miles equals 1,618 kilometers. Notice that the 1,000 doesn't change. Notice that the equal sign doesn't change. Notice that the punctuation, like the comma here, doesn't change. So toUpperCase is only going to affect the case, so it only affects the case in the letters. And it depends on how you install Java on your computer as to what constitutes a letter. I mean, you know, the Greek, if you have a Greek installed as your default alphabet, then it's going to convert lowercase alphas to capital alphas and lowercase betas to capital betas and so forth. Similarly, the lowercase would do the same thing for whatever language you have installed on your system as your default communication language. So this gives us a little bit more information about how strings work. The idea that we can build strings using the string literal or the string constructor or through a concatenation process. The concatenation process doesn't even have to be on the same line. The idea that we should be using dot equals to compare if two strings actually have the same contents, but we now have another tool, this dot equals ignores case, which helps us deal with some situations where the user may not type it in a response exactly as we expect it, but if I want the user to type in yes, it shouldn't matter whether or not he has his cap locks on or has lowercase letters in his yes. The thing is, we should be able to use equals ignore case to make sure that what they type in is the same as what we're expecting. And this is kind of a, let's be reasonable about this. I don't want to have 8 different comparisons. comparisons for a three-letter word, covering each uppercase and lowercase possibility. We also have these two other methods we talked about, the toUpperCase and toLowerCase. So I could, in fact, take my strings.toUpperCase and compare it to some other strings.toUpperCase. So I could take this and compare S4 dot to uppercase dot equals ignore case S1, or I could actually just say dot equals S2 dot to uppercase. And because of the nature of the immutability, running the toUpperCase on S4 doesn't change S4. Running toUpperCase on S2 doesn't change S2. So if I could do a system.out.println this, close parentheses a third time, even though at the very next line I could print out S4 and a space and S2, and I'll find out that their two uppercases are the same, even though the two uppercases are the same, even though the strings themselves are not equal to each other. So this is another way that we could test equality while ignoring the case. Of course, the dot equals ignore case is a little bit easier to type, a little less heavy on the parentheses, so that's definitely something to consider. So once again, this is Mr. Potter. Thank you for watching. Have a great day.